Max Carl Ernst Ludwig Planck was born on April 23, 1858, in Kiel, in what was then the Kingdom of Prussia. From his earliest years, he spoke of wanting to understand the deepest mysteries of nature. His father was a law professor, his mother a cultivated pianist, and the family dinner table often resonated with discussions of philosophy, literature, and science. Young Max absorbed these conversations, yet he found himself drawn most irresistibly to physics and mathematics. Entering the University of Munich in 1874, Planck studied under the great thermodynamicist Gustav Kirchhoff and the mathematician Philipp von Jolly. He quickly distinguished himself with his clear thinking and meticulous attention to experimental detail. In 1878 he moved to Berlin to work with Heinrich Grenfeld, but it was under Hermann von Helmholtz and Gustav Kirchhoff that he began his doctoral research. By 1879, at just 21, he earned his Ph.D. with a dissertation on the second law of thermodynamics, an early indication of his lifelong fascination with the relationship between heat, energy, and the fundamental laws that govern the physical world. After a brief stint as a lecturer, Planck secured a professorship at the University of Kiel in 1885, then moved to Berlin in 1889 to succeed Kirchhoff. There, in the newly established Institute for Theoretical Physics, he delved into one of physics's most perplexing puzzles, blackbody radiation. Classical theories predicted that an idealized, perfectly absorbing object heated to incandescence would emit ever-increasing amounts of energy at shorter wavelengths. An ultraviolet catastrophe that clearly contradicted experience. For years, Planck wrestled with that inconsistency. He refined his analyses of experimental data, painstaking measurements made by others of the spectrum emitted by heated cavities, and found that existing equations could not fit the observations except by inserting ad hoc corrections. In December 1900, in what he described as an act of desperation, Planck introduced a mathematical fudge. He assumed that energy could only be emitted or absorbed in discrete packets, or quanta, of size proportional to the radiation's frequency. This small constant, later named h, Planck's constant, allowed him to derive a formula that perfectly matched the observed spectrum. Planck himself did not initially grasp the full significance of his assumption. He viewed quantization as a formal trick rather than a profound shift in understanding. But Albert Einstein seized on Planck's quantum hypothesis in 1905 to explain the photoelectric effect, arguing that light itself came in quanta, or photons. Suddenly, Planck's constant became the cornerstone of an entirely new branch of physics, quantum theory. Though reluctant at first to accept the radical implications, Planck famously quipped that God does not play dice. He nonetheless pursued the theory's development with characteristic rigor. Over the next decades, he guided a generation of young physicists, including Niels Bohr and Erwin Schrödinger, toward deeper explorations of quantized systems. In 1918 he received the Nobel Prize in Physics, in recognition of the services he rendered to the advancement of physics by his discovery of energy quanta. On a personal level, Planck endured profound tragedy. During World War I, his eldest son, Karl, died on the battlefield in 1916. Senior Planck watched Germany's defeat, the collapse of the Kaiserreich, and the tumult of the Weimar Republic. In 1937, his second son, Erwin, was executed by the Nazi regime for his involvement in the failed assassination attempt against Hitler. Planck, himself never a political firebrand, nonetheless appealed, unsuccessfully, to preserve scientific freedom. He remained in Berlin through the war's devastation, his institute ransacked by bombs and occupying armies. In the cruel winter of 1945-46, as Soviet troops encamped around Berlin, Planck, then 87, endured hunger and cold. Only a trip to X-ray his own blindness in one eye revealed his resilience. He returned to rebuild his home and salvage the shattered remnants of his life's work. In October 1947, he summoned the last of his strength to attend the Peace Palace in Paris, where survivors of science paid tribute to his role as the patriarch of quantum theory. When Max Planck died on October 4, 1947, he left a scientific legacy that would continue to shape our understanding of the universe. From the bound quanta that underpin the digital age to the probabilistic foundations of quantum mechanics, Every laser pulse, every semiconductor switch, every MRI scan carries his constant H in its heart. More than a century after that desperate act of 1900, Planck's quantum remains a testament to the power of a single insight to transform science, and through it, the world.